our next topic is modulation. Modulation in communication electronics. So the basic principle of entire this communication electronics is modulation, means modification, modifying the properties of information signal. Okay. So basically, what is modulation and what is the need of modulation is the primary agenda. Need for modulation. So basically, when you try to communicate to longer distances, let's say you want to communicate people beyond this room. I mean, within this room, I can talk normal voice. Beyond this room, I may have to use the speaker, microphone. I need a loudspeaker. Beyond that, if you want to communicate beyond the college premises, I can use bigger loudspeakers. Beyond that, so just by increasing the intensity of sound, we cannot communicate to longer distances, right? Another possibility, during normal communication, the problem is noise and interference from other signals. Like if somebody else is also talking, class will be at full disturbance. I cannot communicate properly, right? So then, they are the basic issues with normal communication, where sound waves are being transmitted, right? The problem is long distance communication. Energy required for transmission and size of antenna or whatever transmitter. Let's say if you are using loudspeakers, you have to use bigger and bigger loudspeakers. And another problem is noise. Multimedia transfer. So, if I want to transfer audio, video, and other data, So multimedia transfer may not be possible under normal circumstances. Okay. So at most we can transfer audio. Right? So these are the basic issues with normal communication system where sound waves are being transferred or transmitted through air. So alternative is we go for modulation. Modulation means we are mixing the given signal or superimposing the given signal onto a high frequency signal. Okay. So that will avoid all these problems. High frequency signals. So modulation. What is modulation? Mixing the audio signal with the high frequency signal. Modulation basically means mixing. And more specifically, modulation means modifying. Modulation means modifying the properties of what? Modifying the properties of carrier. So when you superimpose the audio signal onto a high frequency signal, what happens? Long distance communication. High frequency waves can travel longer distances. We don't need to worry about much. So compared to normal audio signals, this modulated signal can travel longer distance. Next one, energy for transmission is also lower because losses are lower. So they can travel longer distances without any attenuation because of high frequency. So these normal audio signals cannot travel longer distances. They require high energy. They require very big size of transmitters like loudspeakers and all. So noise, interference, everything can be overcome by using a high frequency signal. So what are the things? One, long distance communication is possible. Energy for transmission is very low compared to audio signals and normal communication medium. And size of antenna or size of transmitter can be very low. Even our cell phones are able to capture the signals. Small nano size or micro size antenna is now able to capture the signal and is able to transmit the signal. Next, noise can be separated because we are sticking to a particular frequency band. So noise can be avoided. Interference with other signals also can be avoided because we are sticking to a particular frequency. So when we are calling somebody, so in the entire band, a particular channel will be assigned to you. So whatever you speak will be superimposed onto that particular frequency and it will be transmitted. So the entire information will be transmitted into air. So wherever the key you have entered matches with the other person's phone number, they will be able to decode the information. So therefore we will now tune to this particular frequency and receive the information whatever you are transmitting. Right? So the key is their phone number and your phone number. So once you dial a particular person, whatever channel you are choosing, the other person's phone also will tune to that particular frequency. So you can avoid interference with other signals, you can avoid noise, and multimedia transfer is possible. You can at a time transfer audio, video, and all other sorts of information can be transmitted using a single channel. And what are the other things? What are the other advantages? Channel specific, transmission medium, so you can tune your signal in accordance with the transmission medium properties. Like if you are using optical cables, you can tune your message into optical signals, or if you are using normal cables like electrical signals. So transmission medium properties can be tuned, or you can tune your information message in accordance with the transmission medium. So these are the basic advantages with modulation. Right? So now comes the first and foremost most simplified type of modulation, it is amplitude modulation. So when you consider the information signal as a wave, different properties of wave can be altered. I mean, the properties of wave includes wavelength, frequency, amplitude, phase. These are the basic properties that describe a wave. So you can tune, I mean, these two are connected, like one is in space domain, another is in time domain. So you can tune anything, any of these three basically, frequency, amplitude and phase, to alter the properties or to achieve modulation. Okay, so I am considering a carrier wave. So it is given by DE-C is equal to VC sin omega c t. VC is the amplitude, this is the instantaneous displacement. And I am considering modulating wave. Or information. It is EM sin omega mt. Now I try to modulate or modify the amplitude of the carrier wave. So this entire modulation process is modifying the properties of the carrier. Okay, in accordance to the modulating signal. So I am defining after modulation. So after modulation, the amplitude of carrier wave is given by, so I have to define that VC is equal to modulated wave amplitude is original amplitude plus the entire modulated signal Vm sin omega nt. So the modulated wave so I'm just modifying the amplitude, I'm not disturbing the frequency or the phase. This is DC plus Vm sin omega nt sin omega c. Call that as modulation index. M is the modulation index. So here no frequency change, only amplitude change. So now I try to draw the wave pattern after modulation. Let's say this is EC. Some high frequency wave, carrier wave. EM some low frequency wave, maybe an audio signal or video signal, whatever it is, electrical signal. So sound waves or audio signals, everything is now converted to electrical signals. Now after modulation, what is the amplitude of the carrier wave? Frequency is not changing, amplitude, original amplitude plus Vm sin omega nt. So we have to keep the original amplitude. We have to keep the original amplitude plus this omega m. here also. So this is the positive half cycle. For the negative half cycle also the same wave acts over and above the original amplitude. So original amplitude is intact, and over and above that this Vm sin omega t adds up. That Vm sin omega t sometimes may be positive, sometimes may be negative. So here the only assumption is amplitude of carrier wave is larger or at least or at most equal to the amplitude of modulating wave. So you won't see any overlapping. If they both are equal, this negative peaks may join together. If they are not equal, I mean if the modulating wave has lesser amplitude, there will be a small gap. So the final signal is now becomes this. So we will have a profile. This is the case where Vc is greater than Vm. If it is equal, these two profiles will superimpose. If both are equal, negative Vm will be equal to positive Vc. So we will say 0 dot. So here Vmax is equal to Vc plus Vm. V minimum is equal to Vc minus Vm. So the modulation index can be defined as Vmax plus V minimum by Vmax minus V min. So when I add both, we get twice Vc. When I subtract, twice Vm. The two gets cancelled. So here maximum possible value for Vmax is what? So maximum possible value for M is 2Vc, and V minimum is 0. And the same 2Vc minus 0. So maximum possible value for modulation M max is 1. And M minimum so minimum possible value for Vmax is Vc, in that case V minimum is also equal to Vc. That should be dismissed. The minimum possible modulation is 0. That we have to see. So maximum possible value for M is 1 and minimum is 0. Yeah, number wise it is infinity. We have to see that. I will check and confirm. So in this expression, M can take at most 1 or it may go up to 0. So that I will confirm through the equation. So when M is 0, you will be left with only the original signal, and when M is 1, you have modulated signal, maximum possible modulation. We confirm that how M becomes 0, why not it is infinity. Okay, in total we are modifying the amplitude of the carrier wave in accordance with the modulating signal. Okay. So the modification in amplitude are given by this modulation index, and this M value could be 1 maximum and it would be 0 for minimum. Okay. So we wrote this equation in reverse. It is Vm by Vc. So the negative sign comes in the numerator. When you subtract, you will get Vm, twice Vm, and when you add, you will get twice Vc. So M minimum is 0. M minimum is what? So at the minimum, V maximum is equal to Vc, V minimum is also Vc. So V max minus V min is 0 and V max plus V min remains intact. So minimum value of M is right? So you can verify these things in your lab session, like what frequency and what amplitude. You can control the frequency and amplitude of carrier wave or modulating wave, and check how that final signal shape changes.